this is Johnny, recording my Lab 7 demonstration for SRT521NAA. So, without further notice, let's get into the first code. So, this is a pretty simple code. This is just creating a dataset called randompoints.csv, and we're basically using np-random. It's a module that basically generates values between 0 and 1, and we're basically saying for it to create 100 rows and 2 columns worth of data, and we're setting this to data, and then we're creating a data frame using data to essentially fill the columns X and Y. And then we're writing it as a new CSV. I'm not going to run the command. I'll just show you the input or the output just because I don't want to overwrite the one I currently have. So yeah, that's the data set. So from there, we have scatter.python. So this one basically aims to plot the CSV that we created earlier. So yeah, it's reading the randompoints.csv that we made earlier, and then we're making a variable called k-means, and this is where we're calling upon the k-means cluster module, and we're setting the amount of clusters here. So we're setting it to 3 and random state to 12 just for it's just a state, so like for replicability, and we're asking it to fit it into a data frame. And then here we're creating a variable called centroids. So this is where we're calling upon the centroids from the module from k-means, and then here we're basically setting the coordinates for x and y, and we're using the first and second column from the randompoints.csv to fill the x and y coordinates. From there, we're basically saying to plot it under a scatter graph, and to plot the x and y coordinates that we got from earlier. This is just a color, so we're basically saying the color of the points is going to be whatever color that the k-means label is. And then cMapVertice is basically just the color of the mapping theme, so it's vertice, so it's like a color gradient. And then from there we're doing the same exact thing just for the centroids, and we're setting it to red, and the size of it is going to be for 120, and it's going to be bigger than all the other points. For marker, we're setting it as an O, or a circle, if you will. And then here we're just plotting the title and the labels of the graph, and then we're displaying the graph. So I can run this one just for demonstration purposes here. So there you go, you can see the graph, the points, the colors of the points that go with the nearest cluster will all share a color, as you can see. There's 3 clusters, so that works. That's the next code I can show here. So we can do calculations. So this one is essentially looking to use the random points, the random point CSV that we got from earlier, or that we generated from earlier, to essentially use that and calculate the WCSS and silhouette score, referencing the data points from randompoints.csv, and it's going to calculate it for the range of 10 in between 2 and 21, and it's going to list it all out. So line 9 is essentially where we set it to apply the k-means cluster calculation. on the data frame to which each value is basically set to a map point. And then it's going to be, that value is going to be stored as a list in k-means cluster. And we're just setting the values here, which I explained earlier from the previous code. And then again, we're doing the same, just for WCSS calculations to WCSS. And then we're doing it for the silhouette score. And then from there, we're basically writing all those values to a data frame, to which it's going to have 3 columns, K, WCSS, silhouette score, and then respectively the variables that are holding all the list is going to be printed in the respective columns. And then we're going to save all that to kmetrics.csv. So I'm not going to run that, but I will show, because I don't want it to overwrite. As you can see. And then lastly, we have, where is it? Lab7plot.python. So this is essentially just plotting out the values from random point CSV and kmetrics into 2 graphs to display. So again, we're reading this the 2 CSVs for random points and kmetrics. We're pinning out the size of the figure that it's going to display. And then line 11 is where we're setting up the subpoint grid with 1 row and 2 columns, and then the first subplot for the following plot command, essentially. And then we're basically plotting, we're creating a line plot with the WCSS values here. And then here we're just printing the, or not printing, but labeling the title and the X and Y label. And then we do all the same thing, but for silhouette score. And then we're essentially, this is to format it, so it's going to tighten up the space in between for better fitment of the display of the graph. And then lastly, it's going to display the graph. So run this. As you can see, those are the 2 graphs. The other codes are just a repeat, just modifying the target CSV to the PE header is what I used for task 2. So it's the same thing, just targeting towards PE header. So I'm not going to show that, but yeah, that's my lab demonstration.